Sun. It gives us heat, light, warms our seas, creates weather patterns, and does so many other wonderful things. Without it, our world would be a desolate rock. It helps us, but did you know it could also hurt us? First issue I will be discussing are coronal mass ejections, or CMEs. CMEs occur when the sun spits out radiation and plasma in different directions, which can cause dire consequences for the human race. Next, let's talk about magnetism. Magnetism is one part of dual force. Electromagnetism, electricity makes magnetic fields, and magnetic fields make electricity. This is all very important because our sun has plasma that has electrically charged protons and electrons that create a magnetic field. When it moves, it shapes particles as they flow. The particles are stuck in a dynamic feedback loop called dynamo, making the sun's magnetic field active. Plasma turns and turns around itself, making the magnetic field get all twisted up and thus making magnetic knots. The topic I will be discussing are solar storms. I've already discussed one type of solar storm, which are CMEs. The next type I will be discussing are solar flares. Solar flares come from hotspots of magnetic energy from the sun's surface. It releases a huge amount of energy, particularly X-class ones, before eruption. The energy is in twisting magnetic field lines that are unstable. Earth's atmosphere protects us from the worst of its side effects of the solar flare by absorbing the shots of X-rays in the atmosphere. The next type of solar storm I will be discussing are the smaller ones. They are smaller, but they can be just as damaging as huge ones. They can damage satellites, radio communications, and astronauts. The final topic I will be discussing are supersolar storms, or geomagnetic storms. In early times, we would have barely registered this happening. It would probably only look like the sun coming out. It wouldn't affect us in the least bit. Now, because we have machines and wire, this could be a very damaging event. We depend as a society on electricity. If this were to occur now, we would lose computers, lights, navigation systems, or water supplies. This system would fail, and hospital generators wouldn't work in the latest. The latest geometric storm that was recorded in history was in Quebec of 1989, called the Carrington event. Massive auroras happened as south as the Caribbean. The only modern technology we had then were telegraph systems. All of our devices failed, then shocking the operators, shooting out sparks. If an event like this were to take place again, it would take years or even decades to get the grid up and running. Solar storms are not preventable, but we can stop the side effects. Luckily, we have scientists who watch the sun and can see up to a few hours to days on if CME is going to happen. We also have engineers who work on the system that keep it going, are also aware of the possible threats from solar storms. Transformers and substations can be powered off, and engineers can open more lines to dissipate the overflow of energy. We have come up with a variety of ways to deal with the solar storms. We always have to be on guard, but this risk is definitely manageable.